Hello there. I'm Ryan Chan, founder and CEO of Upkeep, and today we're talking about preventive maintenance, its importance, and how to optimize it. We'll also touch on some common examples and the right strategy on when to use it. I'll guide you through the process of setting up an effective preventive maintenance program and provide some insights on how to reduce costs without compromising the health of your equipment. Stick around to discover how you can make the smartest maintenance decisions for your business's future. Just like we maintain some things in our daily life and simply use others until they need repair or replacement, the same holds true in a manufacturing or production facility. Sometimes, it simply doesn't make sense to perform preventive maintenance from both a cost and time perspective. For instance, changing light bulbs every year isn't a good use of technician labor and materials. Instead, a company should simply have a system for employees to submit a work request if they notice a burnt-out light bulb somewhere in the facility. At that point, a maintenance technician can be asked to resolve the problem. But conducting preventive maintenance too frequently can waste precious resources. One factor in deciding whether strict preventive maintenance is needed is whether the machine or system being maintained would have a high impact on the utility of the facility. A burnt-out light bulb, for instance, would likely not result in much lost productivity for an extended period of time. However, in other cases, preventive maintenance is necessary to avoid millions of dollars in unscheduled downtime. For instance, a piece of vital machinery in a manufacturing plant that produces thousands of dollars of product every hour needs to be optimized as much as possible. Taking a reactive maintenance approach here is not an option. Facilities should follow the equipment manufacturer's recommended maintenance schedule, while also considering the company's unique usage and experience with such a piece of critical equipment to create a preventive maintenance schedule. So, what exactly is preventive maintenance? It's a type of proactive maintenance that seeks to keep assets in good order by anticipating when there might be issues. Rather than waiting for equipment to accrue issues or break down altogether, preventive maintenance reduces unscheduled downtime and major repairs by taking care of key components before something goes wrong. The goal of preventive maintenance is to increase asset lifetime by preventing excess depreciation and impairment or untimely breakdown. This maintenance includes, but is not limited to, adjustments, cleaning, lubrication, repairs, and parts replacements. One of the first steps in implementing a preventive maintenance program is determining which systems or pieces of equipment should be included. It's best to start with your most critical pieces of equipment first. To identify those machines, think about the following questions. First, how bad is the worst-case scenario? Second, what is the likelihood of a breakdown? Third, how much will it cost? And fourth, is there a preventive task that can mitigate the failure? Let's consider 3 common examples to illustrate when preventive maintenance is needed or not required. Reviewing the 4 questions we just discussed can help us determine the best maintenance actions moving forward. One common example used to illustrate a task that does not require preventive maintenance is replacing light bulbs in general office space. The worst-case scenario is a light bulb burns out. Since office space frequently has more than one light bulb in a single area, the consequence of a burned-out light bulb is very minor. Although the likelihood of a light bulb burning out is fairly high, the cost of new light bulbs and labor of changing them can also be high, especially if done while the current light is still functioning. A preventive task could mitigate failure, but, given the low impact of a burned-out bulb, is simply not warranted. In this case, the best course of action would be to run to failure or wait until a light bulb burns out to submit a work order for a maintenance technician to take care of the problem. On the other hand, lubrication of critical equipment is often used as an example of necessary preventive maintenance. Most people are aware that regular oil changes on vehicles is an important maintenance task to keep their car engines in good working order. The same is true of many different types of manufacturing equipment. The worst-case scenario in this situation is a critical piece of equipment breaks down and stops production. Depending on how long the repair takes, whether replacement parts are in stock, how long new parts would take to arrive from a supplier, whether labor could be redirected, and the value of goods produced on that line, a company could be looking at thousands or even millions of lost dollars per day. If the equipment runs constantly, the likelihood of breakdown is fairly high. However, the simple preventive maintenance task of having a technician lubricate key components is not only possible, but has a high likelihood of mitigating risk and is relatively inexpensive compared with the cost of a breakdown. There is no question that preventive maintenance is warranted in this case. Air filter changes on heating, ventilating, and air conditioning, or HVAC equipment is one of those questionable preventive maintenance items. The worst case is the facility's HVAC system goes down, yet the likelihood of that happening is low. HVAC systems will still run with a clogged filter, but efficiency is reduced, and other parts may be stressed as a result. The task of changing the filter can mitigate risk, and the cost of a new filter is relatively low. Therefore, it's probably a good idea to change the filter. But the next question is, how frequently? Industry experts disagree about the frequency. Recommendations vary from between every 3 to 9 months. Choosing to over-maintain something like filter changes can add unnecessary costs over time. However, waiting too long can cause inefficiencies and shorten the lifespan of an HVAC system. Due to the specific needs of different assets, the type and amount of preventive maintenance required varies. Because of this, it can be challenging to establish a successful preventive maintenance program. A good rule of thumb is to start with a time-based preventive maintenance program, which dictates that a particular piece of equipment should be inspected, cleaned, or maintained daily, monthly, yearly, or at some other predetermined interval regardless of usage. This is akin to changing the oil in your car every 3 months or your furnace filter every 6 months. Although it's more work, another starting point would be performing reliability-centered maintenance, or RCM, to fully define a cost-optimized maintenance program. This type of program can pay significant dividends in the long run. In some cases, you may want to consider a user-based maintenance schedule, which uses meter readings to determine when maintenance activities occur. This may be based on things like mileage or number of hours used. Heavily used equipment should be serviced more frequently than underused machinery. For example, you'd want to change the oil in your car every 3,000 miles, even if you drove that distance in 1 month instead of 3. Usage-based maintenance is generally the best method. This can help you increase preventive maintenance if your operating conditions ramp up, as well as prevent over-maintaining equipment, which can result in wasted resources. Some maintenance tasks can actually harm equipment if done too frequently. For example, over-lubricating a part can cause excess grease to actually damage other parts of the machine and cause a breakdown. By tweaking your existing maintenance strategy, you can optimize the time and money spent by your maintenance team. Some optimization ideas include fine-tuning your planning and scheduling using targeted key performance indicators, or KPIs, and continuously training your maintenance staff on best practices. One of the easiest things you can do is to ask your technicians for optimization ideas. If they have been performing preventive maintenance tasks on the same machines for a while, they may have some insights on what could be done better, or if they believe certain tasks can be eliminated. Although this input is subjective, it can provide some starting points for your analysis, as well as create a culture where technician input is heard. Many experts have developed optimization ideas over the years. For example, several decades ago, a maintenance and engineering manager named John Day Jr. proposed the 6-to-1 rule. It basically asserts that for every 6 preventive maintenance tasks performed, there should be 1 corrective maintenance task. The idea is if you're performing greater than this ratio, you may consider scaling back. If your ratio is lower, you may explore other preventive maintenance tasks that are needed, or whether you're focusing on the wrong areas. Keep in mind that this is an extremely rough estimate. It's important that you use it only as a starting point to help you move to the next level of analysis. If the task is correct and you still detect the failure mode, this can indicate the task isn't being done properly. For example, an incorrectly performed inspection may identify the failure mode. You may want to consider the types of failures you're working on preventing. If they're not critical, scaling back preventive maintenance may reduce costs and labor. Think about whether the tasks you're performing are addressing the correct issue and at the right intervals. Another similar approach to optimization involves the tracking of hours performed on preventive maintenance versus emergency maintenance for a single asset. If you have more emergency repair hours than preventive maintenance hours, you've probably got a problem and will want to do some analysis on the root causes. The long-term goal is to move from reactive to predictive maintenance. As a maintenance manager, you'll want to know the best time to maintain, repair, or replace a part. Implementing an asset operations management, or AOM system, can help you along that journey. For example, a factory maintenance manager can have machine operators periodically log the number of cycles an injection molding machine runs in an AOM system. This data can then be used to analyze which cycle count generated a reactive maintenance work order. A preventive maintenance schedule can then be set to service the machine before that cycle count occurs to prevent failure. Sensors are another technology tool that can help optimize preventive maintenance. For instance, a vibrational sensor can be added to a machine to alert the manager when the machine's vibrations reach a dangerous threshold. This can then trigger a work order. Sensors that monitor temperature, humidity, water levels, and many other factors work in a similar way, providing an around-the-clock watchful eye on all your critical equipment. Every facility wants to reduce its spending, so it makes sense to look at reducing maintenance costs occasionally. However, maintenance costs are often directly linked to equipment reliability, making it tricky to cut costs while maintaining the health of your assets. Explore the following 5 areas where you may be able to reduce costs without affecting the reliability of your equipment. Firstly, schedule optimization. Start by finding the ideal level of required maintenance on only critical equipment. You'll free up technician time by eliminating tasks associated with non-critical assets, as well as reducing the frequency of unneeded inspections and maintenance. Secondly, use KPIs to identify opportunities. You can't fix what you're not measuring. Take a look at industry-accepted KPIs and use them to measure your maintenance efforts. If your wrench time is much lower than industry standards, for instance, and you're seeing low reliability as a result, it's easy to pinpoint the problem and implement a solution. Thirdly, monitor equipment. Without equipment monitoring of any kind, it's difficult to understand the true health of your assets. In fact, with things like condition-based maintenance, or CBM, it's possible to monitor parameters you didn't even know played a role in your equipment's health, like vibration. CBM can help optimize costs for a preventive maintenance program because it allows you to only perform necessary maintenance. For instance, if a part needs to be lubricated only when it reaches a certain vibration level, then that's the optimal time to perform that task. Fourthly, train staff. Strong training programs are a worthwhile investment. You can maximize the efficiency of your facility by setting your workers up for success. With preventive maintenance assistance and tools, your employees can help your preventive maintenance program flourish. The more oversight the operators and frontline employees are able to do, the better your preventive maintenance can be. Lastly, fine-tune maintenance programs. While preventive maintenance is amazing, it's important to remember that it is only one type of maintenance. Preventive maintenance is not the right strategy for every asset in your facility, and misapplying it is a surefire way to waste money and resources. Rather, it should be a part of your overall maintenance strategy. Other important types of maintenance to include in your facility are predictive maintenance, condition-based maintenance, reactive maintenance, and run-to-failure maintenance. A complete maintenance program will incorporate many different types of maintenance in order to help control costs and improve efficiency. Preventive maintenance is extremely important for making sure your equipment runs as smoothly as possible at all times. However, it's important to use preventive maintenance schedules on only those critical assets that require them to avoid unnecessary cost and labor. The amount of money spent on a good preventive maintenance program can reduce equipment downtime, emergency maintenance work, and lost profit due to failed assets. For critical assets, this more than outweighs the initial investment of preventive maintenance implementation. Once a system is up and running, be sure to continue to look for optimization opportunities as well as areas where costs can be reduced. A good AOM system can continue accumulating historic information, providing you with better data on all your critical equipment. With this information, you'll be able to make the smartest maintenance decisions moving into the future. And that brings us to the end of our discussion on preventive maintenance. We've covered its importance, how to optimize it, and some common examples to help you understand when it's necessary. We've also discussed how to set up an effective preventive maintenance program and ways to reduce costs without compromising the health of your equipment. Thank you for investing your time with us today. If you found this information valuable, please consider subscribing to our channel for more insightful content. For more details, visit our website at upkeep.com. Remember, making smart maintenance decisions today can ensure a successful business future.